Okay, today we're going to talk about section 5.6, which is derivatives of the inverse function. The nice thing about derivatives of the inverse function is it's the same process each time. So we're going to take a page back from pre-calc. Suppose we start with y equals arc sine of 2x. We'd like to first rewrite it in terms of sine. So we could rewrite that as the sine of angle y is equal to 2x. Now, we can take the derivative of each side implicitly. Derivative of cosine of y, the derivative of sine of y is cosine of y dy dx. Cosine of 2x is 2. And now we can solve for dy dx. dy dx is equal to 2 divided by the cosine of y. If we wanted, we could rewrite that as 2 times secant, but we won't need to because it's going to work itself out in a moment. So, my answer is in terms of y, but we started in terms of x. So I want to make sure I go back. We can do that at this step if we draw a right triangle. Use a little Pythagoras. So my angle is y. Sine, remember, is opposite over hypotenuse. So we have 2x over 1. We consider that a fraction. Now, we'll use some Pythagorean theorem to find the third side. So if we remember, Pythagorean theorem says that the length squared plus the other length squared equals the hypotenuse squared. Now take your time. A common mistake is that when you take 2x squared, people get 4x, or they just get 2x squared. They forget to square both. So our missing side plus 4x squared equals 1. So then we have b. Our missing side is the square root of 1 minus 4x squared. So we can fill that in. Now, I want to go back. I wanted to know what was the cosine of y. Well, if we go to our triangle, the cosine is adjacent over hypotenuse. That ends up being just the square root of 1 minus 4x squared. So we have 2 divided by 1 minus 4x squared, and that is what dy dx is. And that's the process. We're going to rewrite it, take the derivative implicitly, and then go back to our triangle to fill in this trig function. They can become a little bit more interesting if they have a coefficient in front. So let's try this one. Now, before I rewrite my trig function, I need to move this coefficient, because 3 times arctan is not the same as arctan. So we'll divide both sides by 3. And now we can rewrite it. What angle has the tangent of root x? Well, in this case, the tangent of y over 3 is equal to root x. And I'm going to rewrite the square root of x as x to the 1/2. Now we'll differentiate implicitly. Derivative of tan is secant squared of the same angle times the derivative of the angle, that's our chain rule, dy dx, equals 1/2 x to the negative 1/2. So now we're going to isolate dy dx. It's a little messier, but we can still do it. So dy dx stays. I'm going to multiply both sides by 3. So it leaves me with 3 over 2. That's going to move to the bottom. And I'm going to divide by secant squared. That will be on the denominator. All right, so we have an x in part of it, but we have a y in the other. So let's go back to our triangle. To get that, we'll go right here. So here's our triangle. My angle this time is y over 3. Don't worry, no identity needed, because tangent is opposite over adjacent. Again, this is like a fraction of 1. So we have opposite over adjacent. Now if we use Pythagorean theorem, this squared plus that squared would be x plus 1. So the hypotenuse is the square root of that. Now, another place easy to make a mistake is this is going in, it's 3 divided by 2 root x. It's secant squared down here. So we want to be careful. Well, what is secant? Secant is the reciprocal of cosine. Cosine would be 1 over the square root. So the reciprocal of that is just the square root of x plus 1. And then we're going to square that. I just reversed it, no specific reason. Now, that's handy, because when we square the square root, it's going to go away, undoes it. So we have 3 divided by the 2 square root of x times 1 plus x. And that is our answer. So whether we have arctan, arcsine, we could do, let's do this one. Arcsecant, we'll do one more example. No coefficients out here to worry about, so we can rewrite it. Secant of y is 2/3 x, or 2x over 3. Now, we certainly can take the derivative at this point, because we know the derivative of secant. Or we could rewrite it in terms of cosine. It doesn't matter. So we'll do, it doesn't matter. If you leave it in terms of secant, you just have to be careful when you draw your triangle that you have the sides in the right spot. So let's continue this way. Derivative of secant is secant tan dy dx. Derivative of 2/3 x is 2/3. We'll solve for dy dx. And that is equal to 2 divided by 3 secant y tan y. Okay. So now let's go to our triangle.